Good afternoon, everyone, or good morning, depends where you're dialing in from. And welcome to our webinar today, an introduction to EMC regulations. My name is Jim Regan. I'm the host this afternoon. Before I pass over to our speaker for today, I just want to go over a couple of housekeeping rules very quickly. Firstly, you'll have noticed that you are all on mute. We do this to reduce any potential background noises, ensuring everyone gets the best out of today's event. Next, if you have any questions for the presenter, please use the Q&A box. It should either already be open on your screen, or you can click the icon down at the bottom, the Q&A icon at the bottom of your screen. Just type in your question and press submit. We'll address any questions at the end of the webinar, and if we turn out to have too many questions and don't have time to respond to all of them during the live event, don't worry, we will reach out directly to anyone who asks questions and we don't get to cover them. And lastly, we're recording this webinar for you to access later. So keep an eye on your inbox. We'll let you know when that's available for you. So before we kick off the webinar, I would just like to introduce you to our speaker today. James Nash is an EMC test engineer based out of our Gormley lab in Canada. James originally from the UK and started his career as an engineer in the defence industry before taking on a role as an aerospace EMC engineer in 2013. He now works for us to Sud Americas in commercial, medical and industrial EMC testing. And he is part of a wider EMC team that provides services to customers all across the US and Canada. So with that, let me hand over to James. Thank you very much, James.
Yep, thanks, Jim. Welcome everyone to this introduction to EMC regulations. As Jim said, I'm James Nash, and as a project engineer in Toronto, I will take you through an overview of EMC requirements for taking most products to market, focusing in North America, Europe, and we'll look at some other global markets at the end too. We have a couple of quick poll questions for you to answer next, so we can just get an idea of who you are and where you are in terms of knowledge. It'll just help us with that feedback. So I'll just click the next slide onwards and you can answer this question. I'll give you a few seconds to have a look, and we'll take your feedback and we'll move on. Okay, that's very helpful. I'll hang on a bit longer for the next one if people are still logging in. So this one, what's your main marketing focus? Which area are you looking to market products in, or are you interested in? Okay, thank you for that. And we will now continue with our slides. Now, we're going to be looking at Europe here, and we'll be looking at the EMC Directive, which governs European EMC regulations. Europe has many directives that cover products coming onto the market, and they're found in the official journal. The EMC Directive is one of those, and that'll govern access to European markets for electrical items. So I'll just read through this slide for you to help. This is a quote from the directive, and it will give you an idea of what we're interested in general terms when we're looking at EMC. So all electric devices or installations influence each other when interconnected or close to each other, e.g. interference between TV sets, GSM handsets, radios and nearby washing machines, or electrical power lines. The purpose of electromagnetic compatibility is to keep all those side effects under reasonable control. EMC designates all the existing and future techniques and technologies for reducing disturbance and enhancing immunity. The Electromagnetic Compatibility Directive, and I've put a link at the bottom here at the ec.europa.eu website, which contains the EMC Directive there. Just remember that when you want to have a look at this in more depth. And the directive ensures that electrical and electronic equipment does not generate or is not affected by electromagnetic disturbance. A few more details from the directive, which is mandated, as it says there, this is mandated by EU law. So products going into the EU, which are to be CE marked, must meet these regulations. So Annex 1.1, Clause 1, general requirements. Equipment shall be so designed and manufactured having regard to the state of the art as to ensure that A, the electromagnetic disturbance generated does not exceed the level above which radio and telecommunications equipment or other equipment cannot operate as intended. B, it has a level of immunity to the electromagnetic disturbance to be expected in its intended use, which allows it to operate without an acceptable degradation of its intended use. So those points A and B separate two types of testing. A would cover emissions testing and B, immunity. So for the emissions testing, that statement is concerned with any noise that your equipment generates, and for that point, B, immunity to the electromagnetic disturbances that it might see in its environment. So in the reality, when you come to a testing lab, we will expose your equipment to various electromagnetic disturbances and see how it operates. And just to tackle that phrase state of the art, which is useful to have a look at some of the jargon that is used in these documents. State of the art in this, as used in this purpose, means harmonized standards reflect the generally acknowledged state of the art as regards to electromagnetic compatibility in the Union. So harmonized standards are published in the official journal and use those standards in the official journal to fulfill the requirement of the directive. So state of the art is referencing really the latest standards that have been harmonized in Europe. So moving on to Annex 1.2, Clause 2, and we'll finish up soon with Europe. Specific requirements for fixed installations. So installation and intended use of components. A fixed installation shall be installed applying good engineering practices and respecting the information on the intended use of its components, with a view to meeting the essential requirements set out in point 1, Clause 1, which we just read. So the installation must be tested as they will be installed, so to duplicate as close to possible the EMC performance of the product. So when we're testing in the lab, we want it to be as representative as possible as the installation will be in its final position, basically, when it's being used by the customer. And that's obviously important just so that we can duplicate the environment here and make sure when it is installed, it's installed appropriately. Okay, so Annex 2.2, Clause 2 talks about electromagnetic compatibility assessment. The manufacturer shall perform an EMC assessment of the apparatus on the basis of the relevant phenomena, with a view to meeting the essential requirements set out in point 1 of Annex 1. The electromagnetic compatibility assessment shall take into account all normal intended operating conditions. Where the apparatus is capable of taking different configurations, the electromagnetic compatibility assessment shall confirm whether the apparatus meets the essential requirements set out in point 1, Clause 1 of Annex 1 in all the possible configurations identified by the manufacturer as representative of its intended use. So this is quite a practical element to the directive. When you're bringing your device to the lab for testing, we'll look at different functions of your device. So we may test in maybe more than one operating mode, perhaps where your device is capable of operating in different configurations. For emissions testing, we typically want to test with the equipment operating at maximum current draw. We may also need to take measurements of other operating modes, particularly if different circuits or functions are used. In immunity testing, it is possible that we will be using a different mode for the device that is likely to be more susceptible for disturbances. An important consideration for compliance with the European standards is the technical file. The technical file needs to be built and stored, containing basic information, general description of your device, all drawings, schematics, components, bills of material, harmonized standards used to comply with the EMC Directive, EMC test reports, and safety reports, all in just one folder. This should be straightforward exercise for most designers and manufacturers, and just involve discipline in assembling the required data. Watch when design changes take place and consider whether any further EMC testing is required, as this technical file needs to be maintained with current information. Okay, typical test program might be a CISPA 32, which would be emissions for multimedia equipment. And this, well, there's a variety. Let's say there's a variety of standards that cover different types of devices, but this one I've picked up on because it's quite common. This is the latest for emissions for multimedia equipment, and it replaces what was CISPA 22, EN 55103-1, and CISPA 13, and for various equipment. So it's actually pulled those together. So where you see CISPA 22 would have covered information technology equipment. We also now have audio, video, entertainment, lighting control, professional use, and sound and television, all incorporated into CISPA 32 to make life easier, I think, for us all. Another one to note is EN 55103-2 is going to be withdrawn this year on July 2022. And CISPA 24, which is still in effect, and this is immunity testing, is actually going to be replaced in September this year by CISPA 35. We'll typically test a CISPA 35 at this point, so all equipment coming through labs should be up to date with that one. A good point to remember, practical point for manufacturers and people shipping over to Europe, the EU has no grandfathering rules, meaning so all new shipments must comply with the new regulations. So you might have a product that's designed to meet CISPA 24, and you've got an EMC report saying that. But as the date draws near, 16th of September, at that point, your product will have to be retested to CISPA 35, even if there's no change to the products. So any new products should be compliant with CISPA 35 in this case, and we can't apply the old one at that point. Okay, here's a list of a few European standards. There's quite a bunch of different standards for EMC that cover different devices. We just looked briefly at CISPA 32 for multimedia equipment, but here we have 61326-1, which is measurement control and laboratory use electrical equipment. And this is split, much like the next one, medical, into two environments: basic electromagnetic environment and the industrial environment. This impacts your test program because you will see different levels and limits used. Emissions will be tighter on the basic electromagnetic environment and more relaxed in the industrial environment, whereas your immunity levels will be higher in the industrial electromagnetic environment because of what your equipment will be exposed to. So if you're selling into that market space, then it's good to be aware of the different limits and levels in those standards. For the medical standards, we're looking at a very similar breakdown. So you will see professional healthcare facility environment, which think of hospital, or home healthcare environment, where you might see medical appliances being used in a home environment. And you'll see a similar split there. So a hospital may be a more harsh electromagnetic environment, and therefore our immunity levels will reflect that. They'll be harsher than what you might see in a home healthcare environment. To note, for medical devices, the standard has various appendices which will affect your test program. If you've got a particular device, say, which is covered specifically, it might be life support equipment, dialysis, or something like that. It's critical to know from the medical standard whether there are further tests that apply to your device and different setups. At the end there, I've just noted 60870-2-1, just as another example there. That's telecontrol equipment and systems operating conditions. Okay, now to the United States. So the FCC governs EMC in the United States. So we'll be looking at examples here of unintentional emitters in this list that you see. and they're covered by the FCC. As you can see, for most devices, a supplier's declaration of conformity or certification is acceptable under the FCC rules. Certification is more rigorous and would be including testing at a laboratory like ours. Most people go for certification, it seems, and there you can guarantee your product meets EMC fully. But there is another route, and it's worth exploring. So as you can see, a whole list of devices that FCC covers, pretty much anything you can sell. Okay, there is, if the device is too small, that's, the SDOC. So let's have a look at this statement of supplier's declaration of conformity. We no longer require the FCC logo on the device, which was something in the past which was needed. So that's simple. And simpler than the European system is there's no technical file required. But the two-part statement is required, and this can be put on the device. As you can see, you might actually be familiar with this. You see it on many devices these days anyway. This device complies with Part 15 of the FCC rules. Operation is subject to the following two conditions. This device may not cause harmful interference. And 2, this device must accept any interference received, including interferences that may cause undesired operation. And you see that that's referencing emissions and immunity as we see in the EMC testing. Okay, Japan. Now the VCCI Council of Japan regulates EMC requirements there. It's emissions only, and it's based on CISPA 32. So we'll see very similar to the European standard. The approach is very much the same for emissions. The EMC requirements for Japan are based on CISPA standards for Europe. For example, equipment conforming to CISPA 32 will require these emissions limits. And because it's a national standard, you will be expected to test that device, obviously, at the national voltages. In Japan, that's 100 volts, 50 hertz, and 60 hertz. A single device may go through a test program covering several national standards, it's worth noting. The test regimes may be similar, but immunity levels where they're being used might vary. The unit must also be tested at those appropriate voltages, whichever they are. Okay, so for Korea, we have a little more involvement here. So there is not just the emissions, but immunity. The Korean regulator releases updates to its standard periodically. The EMC standards they utilize are also based on the European standards, emissions and immunity. So they produce regularly these notifications and announcements, which are their updates. So if you are producing and selling into the Korean market, just be aware of the latest announcements so that you can be up to date with the latest standards. Technical requirements for electromagnetic compatibility, that's that particular public notification. The latest being in 2021, and test methods for EMC RRA announcement, and that was last year too. So just as you can see, they are recent, and that was quite a big change in terms of naming. So be aware the EMC standards for compliance in Korea have changed from those days. So give you an example, CISPA 11 testing was very similar, was KN11, so that would be an emissions test, is now called KSC 9811 2019. So the names have changed quite a lot. It's worth looking at the details behind the name changes if there's any change with the testing. As you can see, it's important to be aware of these things. It's likely that in many cases just a name change, but limits and levels may have changed in some of the immunity testing. So detail is important. As you can see, many of these are the EMC tests, and you can see the names on the left. You can see most of the names have changed into this KS standard form. Okay, so now we're moving on to Australia and New Zealand. And this is quite straightforward. Much like Japan, the EMC requirements for Australia and New Zealand are also based on CISPA standards for Europe. Emissions only. For example, equipment conforming to CISPA 32 will require these emissions limits, and they'll be carried out at the domestic voltages of 230 volts, 50 hertz, same as Europe. And of course, Canada. So the Canadian EMC standards are as follows. I've listed them off here. ICES 001 to 005. Industrial, scientific and medical equipment for 001. Vehicles, boats and other devices, 002. 003 information technology, and 005 lighting equipment. Just to read this through for you, interference causing equipment standards, Gen Issue 1, general requirements for compliance and interference causing equipment, sets out general requirements that are common and applicable to all categories of interference causing equipment, unless stated otherwise in corresponding standard. This is very similar to FCC. It's really emissions only in what I've listed here. It's very straightforward, and we often, because of the way the market operates, we often test FCC and Canadian standard at the same time. Okay, so now we've got time for questions or comments.
Thank you very much there, James. Appreciate that. We've actually got quite a few questions come through. Not 100% sure we're going to get through them all because there is quite a few. Let me kick off first with Stefan. Stefan asked a question very early on, and it says, can you please address the OJ with regards to harmonised EMC standards and presumption of conformity? Let me read that again.
Yeah.
Please address the official journal with regards to harmonised EMC standards and presumption of conformity. Stefan, I don't know if you want to expand on that, if you want to pop that into the Q&A again. In the meantime, I'll go on to another question from Brian this time. Brian asks, does the UK still use the same EMC requirements as the EU?
Yeah, that's correct. Yeah, as it stands, even with Brexit moving along, the UK does accept the same EMC reports and standards for Europe.
Just following on from that question, do you know when that's due to change? Is it something you're aware of at the moment?
No, I don't know at the moment.
Okay.
I can answer. Sorry, Jim.
On you go, Chris.
Yeah, it's Chris McDonald here. I work for TÜV in part of the business line in sales, and I can answer that in short. In brief, the answer is it will not change at any time in the near future, simply because it is a daunting task for the UK to rewrite or reissue standards that took years to develop. So for the foreseeable future, they're going to continue to use the EN standards.
Okay, thank you. Next question from Scott. Scott asks, when writing data to a USB as a function of your product, how can you isolate your product from the USB device during immunity testing?
Give us a second, we're thinking, but yeah, we'll come back to that if we can.
Okay, I'll come back to that one in a second then. We've got another question here from Antoine. If a device is meant to be sold both in Canada and Australia, does testing it at 230 volts, 60 hertz, is that sufficient in the worst case, or does it have to be tested at 120 volts also?
Yeah, so we would test it at both voltages. The Canadian standard would have different emissions limits as well, so we need to conform to Canadian standards as well as what Australia and New Zealand require.
Okay. From Renato, does FCC, Japan, etc. have grandfathering rules? You mentioned earlier that the EU doesn't have grandfathering. What about other areas?
Yeah, they do have grandfathering rules that cover EMC. Yeah.
Is that the same everywhere? It's just the EU that doesn't have grandfathering, or is that too simple a statement?
Yeah, like if we were to look into each, we'd probably find some exceptions. So yeah, I wouldn't commit to an answer on that. But as far as that question goes, Europe goes the way. Yeah.
Okay. From Saeed, we have: can EMC testing be performed in-house using basic equipment like spectrum analyzer? Any other suggestions to do in-house testing and troubleshooting?
Yeah, it's a good idea. If you do have equipment to do some pre-testing before coming to the lab and get an idea, there are great expenses with EMC testing. So there are certain equipments that you can pick up. Maybe ESD testing is a very good one. If you do have an analyzer, that's great because you're going to be able to start looking at some emissions and get an idea of the performance of your product. So yeah, where people can do it, it's well worth doing that before coming to the lab. Labs can help out with pre-scans though too, so we can look into things before a full test program.
Okay, Stefan, way back at our first question where Stefan asked about addressing the official journal with regards to harmonised. So he's added more to it. There are generics and family product standards that are harmonised. Are they still publishing the standards in the OJ when harmonised? EN 61000-6-2 has not been published in the OJ as harmonised, but we have seen, but we have been getting requests for them. Please comment if they are harmonised and if they'll be published in the OJ sometime soon.
Hi, it's Min from TwoSit speaking. So what we have to use when you ship the product to the Europe, you have to use the harmonized standard published in the OJ. Even though there's generic, like the IEC standard published in 6-2, for example, or 6-4, you still have to declare compliance to the older standard. So for example, currently the 6-4 is published in 2020, but the current version in the OJ is 2009. You still have to declare compliance to the 2009.
Okay.
Good? Yeah.
I'm good with that. From Annabelle, Annabelle asks, for EMC in the EU, does the product have to be tested at the country's voltage, 220 volts, or will 120 suffice? If a product is tested at 120, can this apply to the EMC in the EU?
No, so typically you're going to have to test a European voltage, 230, 50 hertz, to sell into Europe. And that would apply, so you're also applying a different test method potentially as well with emissions. Conducted emissions and radiated emissions have different limits. So we have to test with the voltage and against the standard.
Okay. I'll just ask a question of my own on top of that. If you're testing a product that's going to be sold in multiple regions, obviously you're going to have to test to multiple voltages. How would you guys typically approach that in terms of like a project?
Hey, James. So for emissions, what we see is that each region wants to see test results for their own supply voltages. So for Europe, we'll test to 230, 50 hertz, because that's the nominal voltage for Europe. And for North America, we test to 120, 60 hertz. And so it goes on for a lot of the majority of the countries.
Okay. Were you going to add something there, James?
No, that's fine. Yeah, that's correct. Yeah, that's fine.
Okay. Time's getting on just now, so I don't think we're going to have a great deal many more questions. Let me see if I can squeeze another two in. Firstly, let's see, we've got one here from Chris. Chris, surprisingly, in Canada, a different person, not our own Chris. What happens if we are non-compliant? If I can throw that to Chris.
For me?
Yeah.
So non-compliance, in terms of European compliance, there are a number of issues that can occur with non-compliance. You first have to look at who regulates the CE marking process. For 90% of products going into the European market, the EC Commission is the governing body. It's enforced by national authorities, for example, SWEDAC, BAPT, BABT, and anyone can challenge your CE mark. So national authorities, customs officials, vendors, competition, end users, random sampling, anything can, because it's an open door policy, it's a self-declaration of compliance to these standards. Non-compliance can mean sanctions in terms of products being removed from the market, a ban from shipping to the market, financial fines, and in rare cases, and I've only ever seen this once in my 16 years here, criminal charges. So for egregious offenses, multiple offenses or death due to use of product, shown non-compliance, technical file not up to date, third-party test reports not in hand, and just a lack of due diligence and care, criminal charges can be laid. So although it's an open door policy and it is a self-declaration of compliance in most cases, that self-declaration does come with the codicil that there are laws in place, EMC, electrical safety, machinery safety, et cetera, that govern your access to the marketplace. So yeah, for non-compliance, there are some harsh penalties if you don't follow the guidelines, the rules, the laws.
Okay, that's fairly comprehensive. Let's finish off with one last question. This is another question from Saeed. Is having an EU authorised representative mandatory to sell products to the EU for IT electronics equipment?
It is, yeah. That's also the same with North America. But yeah, you must have a representative through which to sell. Yeah, that's correct. Okay
then. Well, I just want to end the webinar then by saying thank you, James. Really appreciate you taking the time to do this. Also appreciate your colleagues joining, Chris, Sanjeev and Min. But most of all, thank you to all of our attendees. We didn't get to all of the questions, but I will take note of all these questions. James and his team will reach out to you individually and send you an answer. As I said at the beginning, the webinar has been recorded. It should be available in the next, I would say, hour or two. But just keep an eye open on your inbox and you'll get an email telling you when it is available. Again, thank you very much for joining us. This is hopefully the first in many EMC webinars to come up. So keep an eye on your inbox. If we host others, we'll let you know when they're going to be. So again, thank you very much and a good afternoon to everybody.